Hi everyone, welcome to homework 2.3. So today we looked a little bit more at functions. I'm going to go over the homework and then after the homework I will go back over some of the classwork. So function f gives the temperature in degrees Celsius T hours after midnight. So that's a key point, that the hours are not the time, the hours are how long after midnight. Function f gives the temperature. So whatever the input is for hours, then the output is the temperature. So I'm going to go ahead and label that just for myself so I remember. And then it says, choose the equation that represents the statement at 1:30 p.m. The temperature was 20 degrees Celsius. So 1:30 p.m. after midnight is actually a decent amount of time after midnight. So from midnight to noon is 12 hours, plus from 12 to 1:30 is another hour and 30 minutes. So that would be 13 hours and 30 minutes after. And so this would be D, where we have a 13.5 hours. It wouldn't be this because it says T hours after midnight. The input isn't the time, the input is the hours, the number of hours after midnight. And these can be tricky because you see that 1:30 and you see 1:30 here, but again, we're calculating the number of hours since midnight. Number 2, Tyler filled up his bathtub, took a bath, and then drained the tub. The function b gives the depth of the water in inches, t minutes after he began to fill up the bathtub. Explain the meaning in this situation. So t is the input. Remember, it's almost always a function of time. And the depth of the water is your output. So we're going to say at 0 minutes, there are 0 inches of water. All right, B1 is less than B of 7, means that 1 minute after there is less water, less inches of water, than after 7 minutes. And that makes sense because as we're filling it up, there should be more water happening, right? B of 9 equals 11 means after 9 minutes, there are 11 inches of water. Oh, I'm getting so many ads here. Okay, there we go. B of 10 equals B of 22 means after 10 minutes, the water level is the same as after 22 minutes. So this could mean that at 10 minutes we stopped filling up the tub. It could mean that we filled it up more than that, and then after 22 minutes we started to drain it, and so then it became the same level again. But all we know is that after 10 minutes it was the same as after 22 minutes. And then B of 20 is greater than B of 40, so after 20 minutes, the water level was higher than after 40 minutes. All right. Function f gives the temperature in Celsius T hours after midnight. So again, we have another certain number after midnight. It says use function notation to write an equation or expression for each statement. So f is our function, t is what's going in the parentheses, which is our hours, and then the temperature, right? So here we can go ahead and say that f of 12 p.m. is 12 hours after midnight, so f of 12. And we don't know what it equals because it's not giving us that, so we can just leave it as f of 12, and that represents the function when the input is 12 hours after midnight. The temperature was the same at 9 a.m. and 4 p.m., so f of at 9 a.m. is 9 hours after midnight, and at 4 p.m. that is actually 16 hours, so equals f of 16. Right? Because from 12 to 12 is 12 hours, and then another 4 hours is 16 hours. All right, this is also normalized as a 2. Realize that could be confusing. All right, it was warmer at 9 a.m. than at 6 a.m. 9 a.m. is 9 hours after midnight, so f of 9 is greater than f of 6. 6 a.m. is also 6 hours after midnight. Sometime after midnight, the temperature was 24 degrees Celsius. So it means that f of t, we don't know what time, that temperature was 24 degrees. Okay, so in that case, we don't know what the time is here. We just know that it was 24 degrees at a given time. Select all points that are on the graph if we know the graph of f, if we know that f of 2 equals -4 and f of 5 equals 3.4. So that would be an input of 2 comma -4. That would be this one. This would be this is our x, this is our y, so 5 comma 3.4. Okay, and those give us our 2 points. Remember that your input here is x, your output here is y. All right, write 3 statements that are true about the situation. Use function notation. So again, we still have our dog walking situation or our dog on the pole situation. And so you want to go ahead and show us f of, for example, let's say f of 0 is less than, let's say about there, right, f of 50. F of, let's find 2 equal points. So let's say, where's a nice even point? This one looks about even and this one looks about even, right? So at that point it is f of, we'll estimate 39 equals f of, that would be here, so that's just before 70, maybe 69 or so, okay? Equal to, so we use an equal sign and a less than sign, and then it says to write 3 statements. So let's give one more, and we'll say that, for example, f of 100 is less than f of 60. All right. Elena writes the equation 6x plus 2y equals 12. Write a new equation that has exactly one solution in common with Elena's equation. No solution. So this is practicing this again, right? Exactly one solution means that it has a different slope and a different y-intercept. So really we could say this is written as 6x plus 2y equals 12. Let's rewrite this as 2y equals -6x plus 12. Divide both sides by 2, we get y is equal to -3x plus 6. All right, so any equation that has a different slope, so I could say y equals 3x plus 5, for example, would have one solution. No solutions in common would mean that it's parallel and it has the same slope but a different y-intercept. Infinitely many solutions means it's the same exact equation, so you can just write it in slope-intercept form, for example, or you could multiply it by 2 and say 12x plus 4y equals 24. That's the exact same equation, but they would have infinitely many solutions if they're overlapping each other, no solutions if they're parallel, and one solution if they intersect. All right, for number 7, it says if f of x equals 3x minus 5, what does f of a equal? So that's when we take this a here and we replace wherever we see an x. So this would be 3a minus 5. If f of x equals 3x minus 5, what does f of 2 equal? Again, we're going to substitute anywhere we see x now. So this would be f of 2 equals 3 times 2 minus 5, or 6 minus 5, which is 1. Here it says if g of x is 3x, and f of x is 2x minus 3, what is f of x plus g of x? So -2x minus 3 plus 3x, we can combine those, and we will just get 3x minus 2x is x minus 3. That's our answer. All right, going back into your classwork really quickly, I'm going to show you this part right here, and then I'm going to go down and show you just a quick example from here. So this is, you just need to tell me what the statement means. So if W is the function that gives the temperature, so that's this, the output is the temperature, and then the input is T minutes after the stove is turned on. So for this one is 0 minutes after starting, meaning they haven't started yet. You could also say that. The water is 72 degrees. You could also say the starting temperature is 72 degrees. That would be fine. This would be after 5 minutes, the water is hotter or the temperature is greater than after 2 minutes. Okay? This means at 10 minutes, it's 212 degrees, and so forth and so on. So you're just writing a description for each of these based on the information you have, knowing that this is the time, and then this is the output or the temperature. For number 2, it says if all the statements in the previous question represent the situation, sketch a possible graph of function W. Be prepared to show where your statement can be seen on the graph. So this is just showing me, for example, W of 0 equals 72. So at 0, it would be about here, right, just under the 75 mark. Erase that. So that would be one of our points. And then W of 5 is greater than W of 2. So whatever the temperature is at 5 minutes should be higher than what it is. Let me change this 5 minutes, for example. If it's here, then it should be greater than what it was at 2 minutes. Let's say it's here now at 2 minutes. Okay. It looks like W of 0 is less than 30, so 30 is going to be one of our high amounts. So after 30 seconds, maybe we're all the way up here. Okay. 10 and 12 seconds later, it's the same. So if it's 212 seconds at 10, it should also be 212 seconds at 12 seconds. So that would be 212 is here, and then it's at 12 seconds, so also here, right? It's about the same. It says W of 15 is greater than W of 30. So when I put this point up here, that can't be. W of 15 is greater, so let's say that's here. Maybe W of 30 is back down here. All right, and then 15, yep, 15 is greater than 30, we got that. So this is a potential graph, right, of the water values, the water temperature values. Whenever it says sketch a possible graph, remember that yours might not look exactly the same as somebody else's. The important point is that your points are correct. All right, this last piece I'm just going to show you an example. So when we see this, this means that we are substituting 0 in for x. So we're writing f of 0 equals, anywhere we see x is 0. So 4 times 0 plus 2. F of 0 then equals 0 plus 2, which equals 2. All right, same thing here. You're going to take -3 and plug it in wherever you see an x and solve using that information. So some of these have decimals and fractions, but you're just doing the same thing. You're just going to multiply with the decimal and fraction. Same thing here. This is the function f, so I need to look at this function and plug in 0 for x. All right, this is the function g, so I'm going to look at this function and plug in 0 for anywhere I see x. And so that would be 0 times 0, 0 squared minus 4 equals -4. All right. So again, you're looking at what function is it, and then what am I substituting in for x. All right. Okay, that is the homework. If you have questions about it or you want me to check it while you're at home, feel free to let me know. Your code word, I have a little piece of paper with poppies on it. So your code word is poppy. Poppy, like the poppy seed or the poppy flower. Happy homeworking, and see you tomorrow.